Let's now take a look at the Pandas package. Pandas package is a very useful tool for data analysis and data processing. It provides many useful input and output operations, say read and write CSV files. We're gonna take a look at that later. Right now, we're gonna be focusing on the Pandas Dataframe, which is one of the most used classes within Pandas. So let's create a data frame called data frame. You'll see that capital letters are used for classes in a lot of Python packages, including RMSP. And that's just standard practice in coding, right? We reserve the use of capital letters for classes, and then we use lowercase for functions. So we already have the indexes. So if you remember, indexes is a 2D array, right? So we are gonna use that 2D array as data within our data frame. One of the nice things with data frames is that we can provide columns. So we can say what each one of these columns are. So let's say the first column are codes for lithology, and the second column are codes for alteration. So the first argument here is just the data. It's usually a NumPy array, or it can be even a list. And the second argument that I'm specifying here is a column. So these are just the two most common arguments that we use for initializing data frames. So let's take a look at the representation of the data frame. As you may recall, if this is the last thing on my cell and I'm not capturing the output is just going to be displayed on the screen with its representation. It's actually columns. So the representation of a data frame is a table with the columns that we have assigned to each one of the columns of our original data. The array becomes our data on the main body of the table, and the indexes here, they are automatically generated from 0 to the length of the table minus 1. So we have 5 entries here, and of course our indexes goes to 4. If I take a look at the function here, I may specify the indexes if I have specific indexes, but in many cases the indexes are not important and we do not need to specify. As with the NumPy arrays and other Python objects, the data frames comes with a lot of methods and functions that we can use. So let's take a look at some examples. So I can, for instance, do a df.head, and this is going to show the first entries of the data frame. Because my data frame is very short, this is less than the default amount of data that I want to show. So just to demonstrate that we can show less, so let's say we want to look at the 3 first entries, so we can specify, but I think it defaults to 5, which is actually the full length of our data frame. So this is a very useful function that allows us to take a quick look at the columns that we have within our data frame and the type of data that that column contains. The next one is the df.describe. So the describe function gives us some quick summary statistics for all the columns on our data frame. So we have lithology and we have alteration, and the statistics it returns to us is the count, mean value, standard deviation, minimum, 25 percentile, 50 percentile, 75 percentile, and max. So sometimes it's very useful for us to take a look at, say, the minimum value, because if we're looking to some grade and we see some negative numbers for that grade, so that means we need to handle the negative numbers. So very useful to take a look at the describe and the summary statistics for each column of our data. We can perform operations with our data frame, and we can assign new values to our data frame. So for instance, let's say I have an array. So this is already in our data frame. So let's just perform some operation to these numbers. So let's subtract 1. And let's say now that I want to use this array to add a column to my data frame. So for instance, I could do a df and then give a name for that column and then equals, and this will assign this array to this derived column that I just created. And we can now take a look at the df.head and see the result. So we have created a new column that we are assigning this array to that new column. So that's one way we can create columns with a data frame. We can slice individual columns within a data frame very easily. So if I do df and then the string, lithology, the name of the column, and run, this is just slicing the data frame. So this is called a series. So each column of a data frame is a series. So a series have a name, which is the name of the column. It has a type, which is the type of the data that's contained in that column. And it also has the original indexes. We can also slice data frames by row. So for instance, I can do df.lock and square brackets, and we can provide a list of indexes, let's say 1, 3, and 4, that will slice the indices 1, 3, and 4, or we can use the slicer that we've been using before. So for instance, I'm slicing from index 0 to 1, so that should give me the first 2 rows of that data frame. Another way of slicing a data frame is to slice by row and column at the same time. So we can use the same function .lock, and here we can specify the column we want to slice and run. So this is slicing the column lithology for the first 2 rows. I kind of mentioned this before. As you can see, when we slice by column, the representation has changed, and that's because this is a different pandas object. So if I do a type and that object, you will see that this is a pandas series and no longer a data frame. So each column of a pandas data frame is a pandas series. And interesting enough, the series will have its functions and methods. But one thing that I would like to highlight is that if I take a look at the values of this series, which is the actual data, and I check the type of the data that is stored on each series of a data frame, we will see that the data frames stores the data as NumPy arrays. And that's not surprising, because NumPy is just a very efficient package for handling data and arrays and vectors. And of course, Pandas is leveraging that on the Pandas objects. Similarly to what we did with the NumPy arrays, we can also slice data frames using the Boolean arrays. So if you remember, we have this keyout array, which is true or false, and we can slice a data frame using the lock function and the keyout. So this should return to me the last 3 rows of that data frame. And I can, for instance, assign that to a different data frame. One interesting fact about what I just did with this slicing is that whenever we slice a data frame, the slice that we created is still pointing to the same memory. So if I try to change some values on this slice, Pandas will do it, but it will warn me. So every time you see this setting with copy warning, that means you're probably doing something that you shouldn't. So the correct way of slicing a data frame, especially if you're planning to modify that slice, is to create a copy. So if you create a copy, then this slice is an entirely new object, and you can do with it as you please. But another thing that you might have noticed is that this slice now has indexes that are kind of arbitrary. It depends on what I'm slicing from the original data frame. It just gets the same indices of the rows that I sliced. Sometimes what we want to do is to say, let's actually do this on another cell. So the proper way of doing this would be to use copy, like I just demonstrated. Or if you want to reset the indices, what you can do is to use this reset index. And if you just reset index, what happens is that the new data frame for this slice will have the indices starting from 0, but it will store the original indices. In many cases, we do not want to store, so we just tell, okay, just drop the indices. So in that case, we reset the indices and do not store the original indices here. And this is also creating a copy. So if I were to modify this slice, that would be safe. To demonstrate how to read a file using Pandas, we are gonna be using RMSP. So to load RMSP, we do import RMSP. So this will import the RMSP package, which we can use to check out a path to a CSV file that's included with the RMSP software. So let's do file path and do rmsp.load example data. And the example data we're looking for is the copper composite. And there are some arguments in these functions. What we are looking for is just the path for this file. And if I set that to true and take a look, it will return the path to that file. Sometimes the first time you import RMSP on your computer, it will take a little bit to load, but it should be faster when you're loading a second time. So this shows the path to the copper composite data file on my drive, and that just comes with the RMSP software. So now to demonstrate how to read a CSV file using the Pandas data frame, we can use the next line. So here we're gonna do df equals pd and then read CSV, and we are gonna provide that file path to this function. And if we do a dataframe.head, it should show the first 5 entries of that data frame. So this Pandas read CSV file is reading that CSV file here, which could be your compositing data or assay or color or survey data. CSV file format is very common for that, but if you want to read that into a Pandas data frame and take a look at that inside the Python and the Jupyter notebook, you can use this Pandas read CSV function. One thing that I notice here is that some of the columns in our data frame, they have NaN, and that just means missing data. So maybe your CSV file will have -999 for missing. You can use the NA values argument when reading the CSV file to inform the reading function that if it encounters those values, that means it's missing data, so that gets converted to NaNs. If we go ahead and do a df.describe to see the summary statistics for all the columns, you will notice that when I go to the elements that I have a lot of missing data, the count, the total number of valid data within this data frame is much smaller than, say, for the coordinates. That just means that there are 499 non-missing copper values. So the statistics that we're looking at here does not count missing data. So the missing data doesn't enter the describe calculations.